Okay, so for next week's lab, we're going to be looking at logistic regression. Logistic regression is very similar to discriminant function analysis that we covered this week. And so we're going to be using the same data set for it. So again, we're looking at consensus, consult, and autocratic, which are different leadership styles. And we're going to be trying to figure out what political level, so whether they're at the municipal or federal level, the individual is from. So basically, we'll be looking at these questions. So using a logistic regression, we want to classify people's political level based on their management style. So that means that we're trying to figure out, if we just know their management style, can we guess better than odds what the what political level they're at? So here is the overall model significant as compared to the null model. So here, null model is 50% of the time. 50% of the time, you're going to be able to guess right. Can we do better? Based on the data that we have from the different leadership qualities. Then we want to see, okay, of the three qualities, are any of them significant? Then this question is looking at more, once we start wanting to interpret it. Okay, what do these results mean? So what are the odds of being at the federal level for every 1 unit increase in consultative management style? So what do the results mean? And we'll go through that. Finally, we want to compare these findings, the logistic regression findings, to the discriminant function analysis. We want to look at the beta weights, the B weights and the classification results, and see, okay, what here is the same, what here is different. Okay, so next, let's run this together. Okay. So here we have the same exact data set as last time. So here, to run a logistic regression, we want to go to Analyze, Regression, Binary, Logistic. So in the dependent, we're putting political level, then consensus, consult, and auto into the block, just using the enter method. Remember, this is just essentially a regression. Under save, we want to check off probabilities. So we want to save, okay, what are the probabilities for each group? Under options, we want classification plots, the Hosmer Lemonschau goodness of fit, iteration history, and the confidence intervals. So classification plots just tells you how well the regression did at classifying individuals. Goodness of fit tells you how well the model fits. Iteration history kind of is useful to know how many steps it took to get to where you are. And confidence intervals are always good, especially when it's something that we don't always get significance for. So here are the beta weights, it looks like. So we have all that. Click paste so that it goes into your syntax file. Should end up with something looking like this. And run. Remember, we're pasting because syntax is your friend and we want to get used to it. Okay, so I don't want to go too far into this because we're going to be discussing it in lab, but maybe take a second and look through this. What do these things mean? Based on these results, fill out these this first and second question. So, is the overall model significant? And of the variables, which, if any, are significant predictors? So, take a second and think of that. Pause the video here and come back already having your answer. Okay. If you didn't pause and think of it yourself, you're a cheater. Cheater, pumpkin eater. It's important to do these stats. It's something that we're kind of missing out on in these virtual labs. So, is this significant? Let's see. Here, block 0. So if we have nothing in there, what does it look like? As I said, we have 50% correct classification. It's just 50 flip of a coin whether things get put into the right category. Here it's just putting everything into federal. So it's going to be right half the time. Here, nothing in the equation. This is just constant. Now, block 1, remember we're using the enter method, so we've entered everything into a singular block. We see here there's 6 iterations until it got to what it considered the most optimal regression. And it's telling us, okay, so remember step, block, and model here all the same because this is the first step. If we had more steps, it would change, but it isn't. So, omnibus test of all of these is significant. So we can say that with, by the addition of the leadership styles of consensus, consulting, and autocratic, we're able to significantly improve our predictions of whether someone's at the municipal or federal level better than chance. So these are different R squares that are corrected in different ways. So essentially this is saying it's overall able to explain about between 33 and 43% of the variance. These vary. Nagle-Kirky really is more liberal. Coxell and Snell is very conservative. And Dr. Jackson will talk about what he prefers you use, really. Okay, and then here we get to see what this classification table looks like. So, compared to, remember when there was nothing in the model, it just put everything into federal, 12 and 12. Here, it's saying, okay, it's guessing that this 9 and these 3 are at the municipal level, this 3 and these 9 are at the federal, and it was right about 75%. So remember, based on this test, telling us, okay, we've done a significant We've significantly improved the model from baseline. Okay, so here is where we get to see what are the significance values for each of the variables. Remember, constant is not a variable. We don't care about it, at least for most of the stats you're going to ever do. So if we look at the significance value here, this one is non-significant, this one is non-significant. And then so it's saying that the only significant variable that is used to predict the consulting, the only variable that was a significant predictor of what political level the individual is at is their consulting leadership style. So this was significant. Down here, the last thing that we get is this graph. Might look a little weird, but essentially what it's saying is, okay, what is the predicted probability for different membership levels? What is the predicted probability of membership given what we have in this model? So essentially, this gives you that backdoor look at how the model is actually running. So it's saying that if it's lower, the predicted probability is lower than 0.5, it's going to say that it's municipal. But if it's higher than 0.5, it's going to say that it's federal. So remember, essentially a logistic regression is just a normal regression with a binary outcome variable, where it's either yes or no, municipal or federal, one or the other. How it does this is essentially, instead of giving you a continuum for that outcome variable, it creates a probability of how likely is it that it belongs to the other group. So here we can see some of these things that were misclassified. So right here, there's F for federal. These are actually cases that should be at the federal level, actually cases that should be at the federal level. So here's the 3 cases that should be at the federal level, but they're misclassifying it as belonging to the municipal level because the result was on this end of this predicted probability graph. On the other hand, there's cases that were a higher value, and so they were misclassified as belonging to the federal level, but really they were at municipal. So essentially that's all it's doing. It's generating a value from 0 to 1 for each of these, and that's what we saved here, right? So if we look here, this is the predicted probability for all of them, and this will match up with what we have here. So we can see, okay, this one's really low. So it's going to have said that this is at the municipal level. Whereas this one's really high, so it would have said it's at the federal level. And so on and so forth. So we can see which cases, what the probability score it gave, and can use that to tell what it predicted it was. So the last part of the lab asks you these 2 questions. what are the odds of being at the federal level for every 1 unit increase in consultative management style, and comparing your findings from this logistic regression analysis to the findings from the discriminant function analysis, the one that we did last lab. How are they the same and different? So compare those B weights and the classification results, and would you interpret the data in the same way? So just compare what we did this time and next time. So from now until the lab, I want you to think about these two questions and try to see if you can see what you come up with. And we will go over them in lab.